Hello, everyone. Welcome to our webinar on AI for secure software development, from architecture to code review. I'm Vladislav Mazan, and together with my colleague Vadim Nevidomy, who is AI solution architect for cybersecurity projects, we are going to share with you something that's transforming how we are building secure software. And I know most of you already think like another AI presentation, right? Yeah, but here's the thing. Here in Apriorit, we are working on cybersecurity software for already over 20 years. And AI revolution is a huge thing for us. Aside from boosting performance, the first thing we're looking for is development security. We will be talking about our personal experience gathered on different projects. This is about practical tools and techniques you can start using to make your development processes both faster and, of course, secure. We will cover real examples, show how we actually use certain tools during software development, and by the end, you will have an idea and a clear roadmap for step-by-step integration of AI into your workflow. So let's dive in. Here's the reality we are all facing. AI is already accelerating software development. We have GitHub Copilot, ChatGPT, Cursor, and dozens of other tools which are helping developers write code faster than ever before. And this is actually critical. Speed without security is a recipe for a disaster. We are seeing organizations ship code like 3 to 4 times faster, but if that code is full of vulnerabilities, you just accelerated your way into the security incident. And the question isn't whether to use AI. Of course, let's be honest, most of our developers are probably already using it. The question is, how do we combine AI's productivity gains while actually improving security, not compromising it? That's what we are here to answer today. And yeah, let's start with the beginning with the landscape. There is an entire ecosystem of AI powered tools emerging, and they are not just theoretical. They were production ready for a long time ago, I think for a few years already. And now, currently, they are evolving like never before. Each day we see a new tool arise. Some are a niche for some specific application, but some may be the next ChatGPT revolution. Who knows? You've got static analysis AI tools that can scan your entire code base and find vulnerabilities that uh, basically traditional tools miss. AI code review tools feels like another, senior security engineer just join your team and ready to assist you anytime. Vulnerability detection systems that understand context, not just pattern matching, and security architecture AI that can analyze your system design and spot architectural flaws even before they become code, which is like sounds great. The key insight here is that these tools work together. They are not replacing your security team. We are not in danger, like everyone is telling you, but these tools are boosting your team and boosting it like heavily. Now that we've covered the landscape of AI security tools, we will talk about GitHub Copilot and its security capabilities. In order to immediately anticipate your future questions, because yeah, I know why Copilot, why not Cursor, why not Windsurf. Copilot is our trusted tool. We use it. We use the Microsoft stack in our company. We are also their solutions partner, and in general, we trust Microsoft solutions in terms of informational privacy and yeah, we work with all their stacks, so we'll be talking about Copilot. That's actually sounds a bit like advertising, but unfortunately, no one pays us for it. And now I'd like to hand it to my colleague Vadim, who will dive deep into one of the most powerful tools in this ecosystem. Vadim.
Thank you. Hello, everyone. Let's talk about GitHub Copilot because it's probably the AI tool your developers are already using. But here's what most people don't realize: Copilot isn't just about code completion, it's becoming a security tool. Copilot can provide security focused suggestions right in your IDE. It detects vulnerabilities as you type and suggests secure alternatives. But the real game changer is what we call agentic development, where multiple specialized AI agents work together. Imagine this: you're writing code, and behind the scenes, you have an architecture agent checking design patterns, a security agent scanning for vulnerabilities, a code review agent checking quality, and performance agent looking for bottlenecks. They all coordinate automatically, giving you comprehensive feedback in real time. This isn't science fiction. This is available today, and we'll show you how to set it up. Let's get specific about Copilot security capabilities. It's trained on billions lines of code, including secure coding patterns and common vulnerability fixes. When you're writing authentication code, for example, it suggests specific secure libraries instead of plain text passwords. When you're building SQL queries, it recommends parameterized queries instead of string concatenation. When you're handling user input, it suggests validation and sanitization. The beauty is that it learns from context. It understands your code base, your framework, and your security requirements. And it's getting smarter every month. Let me show you what AI-powered vulnerability detection looks like in practice. On the left side of the screen, you see vulnerable code, the kind of insecure patterns we encounter in real-world application all the time. On the right, you see the AI security analysis in action. The AI identifies three critical security issues. First, hard-coded database credentials with critical severity. The application stores a database password directly in the source code, which could be exposed in version control systems. Second, SQL injection vulnerability, also critical. Input is directly used in the SQL query, allowing attackers to manipulate the query structure. Third, server-side template injection with high severity. User input is directly inserted into templates, allowing arbitrary code execution. But here's what makes AI powerful: it doesn't just flag the problems. For each vulnerability, it explains the risk in plain English and provides specific fix recommendations. Now let's see the solution. This slide shows the same code, but this time implemented securely using AI suggested fixes and best practices. On the left, you see the secure code implementation. First, database credentials are now loaded from environment variables instead of being hard-coded. Second, parameterized queries. We are using prepared statements with parameter binding, so user input can't manipulate the SQL structure. Third, template validation. We've implemented a whitelist of allowed templates and proper validation before rendering. On the right, you see the implementation guidance that AI also provides. For credential management, it recommends using environment variables or secure vault systems. For SQL injection prevention, it emphasizes using parameterized queries or ORM frameworks and always using prepared statements. For template security, it suggests using template whitelisting and predefined templates instead of dynamic rendering, and never rendering user-supplied template strings. This is the complete picture, not just here's the problem, but here's exactly how to fix it and why this approach is secure. That's how it works in theory. Now let's see what happened when we scanned a real code base. Here's what AI uncovered. A real-world security review using a custom GitHub Copilot mode we called Code Guardian. The system prompt at the top defines it as a specialized AI security analyst who is focused on identifying vulnerabilities and providing clear fix recommendations. Of course, the prompt is much longer, but here's the part of it. We ran this against the real-world code base. The result: 8 vulnerabilities discovered, 2 critical, 3 high, 2 medium, and 1 low. Overall security grade, high risk. Let me highlight the 2 critical findings in the code blocks. On the left, it's TLS verification bypass. See that SSL equal false on line 20. That's hard-coded, completely disabling SSL certificate verification. This enables man-in-the-middle attacks where attackers can intercept tokens and steal credentials. Critical severity. On the right, potential comment injection. The repo variable comes directly from user input and gets passed to a subprocess without validation. An attacker controlling the repository path could trigger path traversal or execute in sensitive directories, high severity. The bottom shows 6 more vulnerabilities. Another critical with tokens in query parameters, 3 high issues including command line token exposure and insecure login, plus 2 medium and 1 low severity findings. What's remarkable isn't just that AI found this, it's the quality. Each includes CWE mapping, line numbers, impact assessment, and of course fixed recommendations. This is AI as your security analyst, reviewing every line before production. Now let's summarize how we can use AI more broadly for secure coding practices. Vlad, go ahead.
Okay, thanks, Vadim. And first of all, I wanted to mention that we would like to see your questions in the chat. And of course, at the end of the webinar, we will address every question you ask. So yeah, let's go to secure coding with AI assistant. Let's just make a brief overview what we were talking about before. Beyond finding problems, AI is actually helping developers write secure code from the start. It starts from the security by design, building protection from day one. AI helps developers apply secure patterns, enforce best practices, and stay compliant as they code. So security isn't just an afterthought, it's part of the DNA of the development, it's the core. Then come real-time suggestions. AI becomes that quiet copilot, yeah, beside you. It spots risky code, explains why it matters, and helps you fix it right away without breaking your flow. And finally, automated refactoring, where AI doesn't just point out what's wrong, it helps make it right. It rewrites insecure code patterns, proposes safer alternatives, and keeps everything functional and readable. So instead of slowing developers down, AI helps them build security right into their workflow, naturally, almost effortlessly. Okay, and now let's talk some numbers. According to the CWE database, 70% of vulnerabilities are introduced during the coding phase. The NIST data indicates that early detection reduces remediation time by 85%. I was looking on a bunch on different research and I always see different information and different numbers. So yeah, let's just look on it. But everything depends on, and each application is unique for that. On our own experience, we can see around 60% cost reduction when fixing issues during development instead of after release, of course. But for example, while looking on the NIST data, they thought it's 30 times more costly than fixing in production. But I guess they are taking their statistics from larger product than we do. So each number can vary depending on the project complexity and scale, but the pattern is clear. Early detection always pays off. Our teams also reporting saving around 50% of their time through AI-assisted code reviews. Instead of waiting for manual checks, developers just get fast insights right inside of their workflow. And some AI researchers claim detection rate up to 90% for common vulnerability types. From our experience, to be honest, these numbers are a bit lower, but for us, that's expected since we typically work with complex systems where vulnerabilities are usually tend to be more sophisticated and harder to catch. So while these figures are approximate and will differ by environment, the trend tells us one thing. AI turns security from a last minute fix into a built in advantage. And now Vadim will show you the practical part of how to implement AI powered code review systems in your development workflow. Vadim, take it away.
Okay, at first I wanted to mention prompting. Here's a pro tip that most people miss. How you prompt AI really matters. Generic prompts get generic results. But if you use role-playing techniques, you get much better security analysis. Try prompting AI as a security architect, like review this design for security architecture flaws and recommend defense in depth strategies. Or as a penetration tester, analyze this code from an attacker's perspective and identify exploitation path. Or as a compliance officer, assess this implementation against DPR and other requirements. Or as a code reviewer, perform a security-focused code review, identifying vulnerabilities and secure alternatives. Different roles give you different perspectives. We recommend trying them all for comprehensive analysis. We tried different prompts, agents, modes at Apriorit, changed prompts, added rules a lot, experimented with different agents. Now let's get back to code reviews. LLM-based code review systems are changing how we review code. They provide comprehensive security analysis, automated vulnerability detection, code quality assessment, and best practices recommendations, all automatically. But here's the key: they don't replace human reviewers, they assist them. The AI handles the tedious stuff, checking for common vulnerabilities, enforcing coding standards. Here in Apriorit, we have very strict ones, finding performance issues, etc. This frees up your human reviewers to focus more on business logic, architectural decisions, and complex security scenarios that require human judgment. The result: faster reviews, better quality, and your security team can focus on what they do best. Let's look at the numbers. This slide compares human reviewers versus LLM-based code review systems using real-world data from multiple studies. On the human side, the picture is challenging. Average review time is 2-3 hours per pull request. Just the initial analysis takes over 20 minutes. For a typical development team, that adds up to thousands of hours annually spent on code reviews. And here's the kicker: human effectiveness drops after reviewing just after 80, 100 lines of code. And it's from our own experience. Now look at LLM-based systems. Average review time drops to 20-30 minutes. That's 3 times faster. Initial analysis less than 30 seconds. Time savings range from 25 to 50 reduction in review time. Merge speed improves by 50% and in some cases up to 4 times faster. The bottom metrics are equally impressive. Code reviewed by AI has a 53% higher likelihood of passing all tests. 13% more lines per code error, meaning cleaner code. CodeRabbit customers report a 30% reduction in bugs, and AI eliminates 80% of trivial PR comments, letting human reviewers focus on what really matters: architecture, business logic, and different complex design decisions. These aren't theoretical numbers. These come from GitHub research, Ferris AI, Smart Dev, and real customer case studies from CodeRabbit, TaskRabbit, and SalesRabbit. The data is clear. AI doesn't replace human reviewers. It supports them.
Okay, I think, Vadim, it's great time to share how we can integrate AI code review into your workflow.
Yeah, let me walk you through how this actually works in practice. 1 second. I guess we need to switch slides.
Sorry. Yeah.
Yeah. It's a 5-step workflow that integrates seamlessly with your existing development process. At step 1, it's code submission. Developer submits code via pull request or version control. Nothing changes here. Uh, on the next step, multi-agent AI system automatically evaluates the code from multiple perspectives: architecture, security, performance, and code quality. At step 3, we have feedback generation. AI generates detailed comments with specific line references, severity levels, and different optional fix recommendations. Then human review goes. Your security team validates AI findings and provides additional insights. This is where human expertise adds value. And after that, at the final step, approved code is merged and deployed to production with confidence that it's been carefully reviewed. The whole process typically takes minutes, not hours or days, and it scales effortlessly.
Yeah, it looks simple. And I think, Vadim, we also mentioned something about architecture in the title. So I think let's share some insights about that as well.
Yeah, let's move up a level and talk about architecture. AI isn't just for code. It can analyze your entire system architecture for security flaws. On the left, you see AI key capabilities: architectural pattern analysis that evaluates your design patterns and decisions, design vulnerability identification that spots security weaknesses in your architecture, defense in depth strategy that recommends layered security approaches, and security layer optimization that helps you optimize controls and mechanisms. On the right, you see practical examples with actual prompts you can use. For example, for microservices security, ask AI to review service-to-service communication for missing mutual TLS. For database design, let it identify weak access controls. For API gateways, check for authentication and rate limiting gaps. For cloud infrastructure, assess IAM policies and network segmentation. For new projects, we often use AI tools with predefined blueprints of different architecture styles. Okay, here's an example. This is a typical e-commerce architecture: load balancer, API gateway, microservices, database, and Redis cache. Looks reasonable, right? But when we run AI security analysis, it finds 12 critical issues like no SSL, TLS anywhere, no rate limiting, shared database with no service isolation, public database exposed to the internet, no data encryption at rest, uh, Reddit with no authentication, session tokens stored in plain text, no request validation, etc. That's 12 critical vulnerabilities in what looked like a reasonable architecture. AI found them all in seconds and provided specific recommendations. This is the power of AI for architecture review. Comprehensive analysis that would take a human team hours, done in seconds. Now let's talk about AI bias in security tool. Vlad, go ahead.
Okay, yeah. And then now let's talk about something really important, and I think a lot of skeptics are there. So AI isn't perfect. Yeah, that's true. And let's talk about something specific, about real biases and limitations you need to know and keep in mind. First of all, model bias. AI learns from historical data, obviously. Basically, it's billions of code lines because we are talking about the coding and the security. And that billion code lines may also include bad security practices and anti-patterns. The second one is similar. If the training data doesn't include a wide range of security scenarios, the AI might simply miss some vulnerabilities. The third one is false positive bias. And in my opinion, it's actually the most annoying one for developers specifically. Sometimes AI flags secure code as vulnerable, not too often, but that happens, which can cause alert fatigue for your team, and that makes your team not really satisfied with AI. But it's not really often. And the final one is framework bias. AI tools often perform better with popular frameworks and might struggle with niche or custom ones. And here at Apriorit, we often use some niche frameworks. So the key takeaway here that everyone should understand these limitations and build your processes around them. You don't need to blindly trust AI. Just validate its findings, especially when it comes to critical security decisions. Okay, so how do we actually mitigate risks while working with AI? It really comes down to four key strategies. The first and the main one, human oversight. Always make sure your security experts or development leaders validate the critical findings that AI produces. AI can suggest, it's fine, but humans still decide. The second one is tool diversification. Never rely on a single system or a framework. Combine multiple AI solutions also with your traditional security tools to get a fuller, more reliable picture. The third one is continuous monitoring. I think it's clear that you need to audit AI recommendations as much as possible. Keep track of false positives, missed vulnerabilities, and how accurately it changes over time. That's how you stay confident in what the system delivers. And finally, last but not least, team training. You should help your developers and your teams understand AI's limitations and when an issue should be escalated to a human expert. Because AI is just a tool, a powerful tool, but it's not a replacement for experience and judgment. The bottom line, AI is transforming security, but unfortunately, it's not magic. Yeah. Use it wisely and always keep people in the loop. And here we go, the next slide about human in the loop design. These are proven patterns for combining AI and human expertise effectively. The first one is validation loop. AI should flag issues, human should validate before action. This prevents false positives from disrupting your workflow. The next one is escalation path. Complex issues automatically should be escalated to security experts. AI handles only the routine stuff. Humans should handle the complex stuff, which AI yet not always, not every time able to address. The next one is decision authority. Humans should retain final decision making power on security matters. and continuous feedback. Human corrections always improve AI accuracy over time. The system gets smarter with use, and using these patterns ensure you will get the best of both worlds: AI speed and scale combined with human judgment and expertise. And the next topic is about quality assurance. Let's say it right away. We were talking with our security experts, and when I told that we need only 2 slides for QA, they were shocked. Like, that's a whole new topic, and we can make another webinar about that, because AI is transforming quality assurance as much as it's changing software development. It's just let's make a short overview so you will have an idea where you can go. The first one, and the obvious one, is documentation and test creation. AI can extract requirements directly from the code and comments, plan tests based on potential risks, automatically write test cases, generate realistic test data, and even check test coverage. All of that we actually already tried on our project, and it works quite well. The next one is test automation and execution. AI supports cross-language automation, automatically builds and runs UI tests, assists with manual testing, and can generate new test scenarios on its own. Here, I would say we still have a lot of room for improvement. While there are a bunch of tools for UI testing, they are pretty limited in their capabilities. Especially, I'm talking about desktop ones. The web tools are pretty good. But my guess is just a matter of time when they will become better, and we will see the other side. And yeah, the next slide about QA. AI also helps with semi-automatic ticket creation and issue prioritization based on customer feedback. That requires some efforts to set up, configure everything, but still it will save you time later. And AI can even forecast collisions based on commits and warn the team about potential feature conflicts before they happen. We are already working with that as well. On the advanced side, it supports root cause analysis, identifies why issues occur, tracks user satisfaction through sentiment and behavior data. With tools like GitHub Copilot, Nathan, and Zendesk AI, all of that is actually real and could be fit right into existing workflows. The result, yeah, faster fixes, better quality, proactive detection, and finally happier users. That's what we are looking for. And by this time, we've covered the full spectrum from architecture to code to testing. Vadim, would you like to wrap things up with our implementation roadmap?
Of course, our implementation roadmap includes 5 phases. At phase one, it's assessment and planning. Start by understanding where you are today, analyze your current workflows, identify the biggest pain points, and define clear success metrics. Most importantly, get stakeholder buy-in early and secure the budget. Then, tool selection and setup. Evaluate vendors like GitHub Copilot, Sneak, SimGrep, and CodeQL. Don't just read the marketing. Run proof of concepts on your actual code bases. Then integrate into your CI/CD pipelines and configure security policies that match your risk profile. Then, very important phase is team training and enablement. This is where many organizations fail. You need role-based training. What works for developers is different from what security engineers need. Run workshops, create prompt libraries, and designate AI security champions who can help their peers. Then, pilot program. Pick 2, 3 diverse projects, different tech stacks, team sizes, risk levels. Track everything. vulnerabilities found, false positives, time savings, and of course, developer satisfaction. Collect feedback and iterate. This phase validates whether your approach actually works. And when you have a working solution, you can scale. Roll out in phases based on pilot success. Establish quarterly reviews. Continuously refine your prompts and rules. This isn't a one-time implementation. It's an ongoing optimization process. The key is to move deliberately, measure everything, and let the data guide your decisions. Now let's talk about key takeaways. AI dramatically accelerates secure development when used correctly. Human oversight remains essential for critical decisions. We can't allow AI do whatever it wants. Start small, measure results always, and scale gradually. Try to combine multiple AI tools for comprehensive coverage. Vlad, can you please describe briefly our recommended resources?
Yeah. To all the listeners, we are coming to an end of our lecture. So we are waiting for your question in the chat. And in the meantime, I would like to share some resources to help you get started. Of course, we already mentioned GitHub Copilot for code assistant. There is also Sneak for vulnerability scanning. SonarQube can also have AI plugins for code quality. You can use OpenAI API if you want for a custom security analysis, and SamGrab, for example, for pattern-based security analysis. So thank you for your attention, and we're looking for your questions. Meanwhile, while we were talking, I have a question to you, Vadim. Like, could you explain how AI is better than some tools like SonarCube? Like, what is the profit of using it?
Okay, I will try. Static analysis tools I usually work on predefined rules, on different vulnerability signatures, uh, patterns in code that easy to spot. But AI reviewer can be more like human. So it's quite flexible. It can understand the overall task that is being solved by some specific pull request. It can analyze recursively dependencies. It can analyze the impact of this change. So it behaves more like a human. And using multiple agents, it can be configured for different perspectives. So you can measure not just security. You can measure performance and find issues there. So AI tools are more like human. It's different. It's not a replacement. They should work together. Static analysis for common coding issues that easy to spot, and AI coding reviewer to uh, be more like human to understand the overall task, assess architecture, and uh, different defined human defined rules.
Okay, Vadim, thank you for your answer. I see one question in the chat. Do you suggest Copilot only for code reviews, or do you have some other applications for that?
I would say Copilot was designed not for code reviews, but for coding at all. But it can be used for code reviews. For code reviews, we have other more specialized tools like Code Rabbit, PR Agent. That is, as I remember, is open source. You can always create your custom solutions for code review using modern LLMs. But there are much more. So uh, it's Copilot Copilot can be used too, can be configured, but now new solutions appear every day, so it's better to try different ones and select the most flexible one that can be uh, applied to your code base, that allow you provide your custom review rules, and that supports your programming languages from your stack.
Thank you. And I see another question in the chat. Uh, how to create such a nice security agent? It just depends on good prompts or something more. Please share some examples. Thank you for the question.
Um, it's in an iterative process. Yeah, prompts are very important. Uh, but also, agents can be configured with certain tools, like and maybe you heard of MCP servers that are very flexible and can be applied to any agent. So uh, yeah, so it depends on uh, agent architecture. So does it require planning or not uh, for its work? Does it require certain MCP tools? For example, it's very common to give agents possibility to read files, to search through code repository, like using something like grep searches. It's very important to uh, give agents ability to understand the syntax of the language, the coding practices of the best practices of the language, using different RAG tools. And context engineering is also very important. So it's important to pass to agents all required information to perform a nice code review. What I mean is, if we are reviewing pull request, it's important to give it the commit messages from this pull request, the link to the task ID from pull request that is being solved, so agent could access it and understand the context, the task that was solved. Also, yeah, it's an iterative process. It depends on prompts, on the context provided to the agent, on the tools provided to the agent, and you will always refine your prompts, your approach, your tools. And it's better to have some kind of versioning system for prompts, for also for tools, to make it more structured, your iterations. And of course, you need some kind of data set for validation your approaches.
Okay, thank you for a detailed answer. And also, while we're waiting, if there will be some questions in the chat, I have just another one. What do you think? Is agentic AI, which are quite evolving lately, will be able to make their own decisions without human overview? Maybe sometime later.
For now, it's possible to give agent such ability. For example, if we give agent ability to uh, execute shell commands, uh, it can do whatever it thinks is good. For example, it can remove all data from your disk. Uh, for example, if it's hijacked with some kind of prompt injection. So for um, critical tools, for critical uh, abilities that we can equip our agent with tools, it's better to get confirmation from the user, because it can be dangerous for now. Maybe later it will be possible when agents are fine-tuned, when LLMs are fine-tuned with more strict security guidelines. But for now, for critical operations, it's better to get human approve.
Okay, thank you. And I see the question in the chat, which I was waiting for, about the compliances that cover all those security aspects, which are the industry's cybersecurity standards. So it's quite a complicated question, and maybe some lawyer will answer you better. But what we are relying on currently is the European Union AI Act. So basically, it's like a broad thing, but they are separating projects by severity. And for example, for high risk projects, which can impact human health or psychology or somehow working with the HR systems, they restrict using AI completely. So just do not impact the human health or well-being. For example, for high priority project, they require full transparency that AI is AI. So we are not able to hide that we are like a human. And overall, a lot of countries currently working on something like that, like in the European Union. And I think we will see something similar in the United States. But basically, we should think about a few things. First of all, we should think about transparency. So everything should be transparent. What are the data we trained on? What are the personal informations? If they are like in GDPR protected reliably, we should make sure that our team is has passed training sessions, that our team knows how to work with AI, what are their bottlenecks, what are their good stuff. So learning, privacy, as I mentioned before, and also another very important thing is risk assessment. So for each project, there should be a risk evaluation considering AI usage, what we should just quantitatively or qualitatively assess the risk of using AI and make sure we will do everything to mitigate these risks. Currently, these compliances are like, let's say, in the initial state, but I'm sure we will see a lot more just in forward in a few months or years. Okay, I see no more questions in the chat, so I guess we will wrap up. Thank you, everyone, for your attention. Thank you for joining in. I hope that you found this practical and actionable. Just a kindly reminder at the end that AI is a powerful tool, and um, we want this tool to be used for software development, but also use it wisely with proper oversight, and you will see dramatic improvements in both speed and security. And sure, if you will have follow-up questions, feel free to reach me or Vadim or our company, and we will be there to help you succeed with AI-powered secure development. Thank
Thank you.
you.
Thank you.